Well, as we've gotten accustomed to doing, we're going to now be looking at rectangles and coordinate geometry. And we are told here that JKLM is a quadrilateral, four-sided figure, and that it has vertices of J, negative 10, 2, K, negative 8, negative 6, L, 5, negative 3, and M, 2, 5. Determine whether JKLM is a rectangle using the slope formula. And so what we're really doing is we're proving that the opposite sides are parallel. And when we're doing that using the slope formula, well, then we got to demonstrate that the opposite sides have the same slope. If the opposite sides have the same slope, they are parallel. Now, since we're in the chapter of rectangles, if we were to determine that all of the sides are parallel, we then also need to prove that the consecutive sides are perpendicular, because for them to be perpendicular means that there's a right angle. And since we're in the world of rectangles, well, those all the angles must be right angles. And for that to be the case, the consecutive sides are going to have to be perpendicular. But we're going to jump over here where I've graphed already JKLM using the vertices that were given. And then we're going to try to determine whether JKLM is a rectangle using the slope formula. And of course, now we should know this already, but slope is equal to y2 minus y1 over x2 minus x1. Also, if we were to get as far as having to try to prove that these consecutive sides are perpendicular, remember, let's say the slope of side A times the slope of side B, that it must equal -1. That's a test for perpendicular. I don't know that we got to do that on this example, which is example 4 in your textbook on page 425. But let's go over and at least start by trying to determine what are the slopes of the opposite sides. All right, so here we've got this quadrilateral graphed. And let's see, vertices J is at -10, 2. And vertices K down here is -8, -6. And vertices L has the coordinate of 5, -3. And let's see, I'll cut my M off, but M has the vertices of M is 2 and 5. So let's start working on the slopes of these opposite sides. And why don't we first begin, let's say over here with JK. All right, so we're doing y2 minus y1 over x2 minus x1. We're using the slope formula. So we're going to use K as our second coordinates, J as our 1 coordinates. So I got -6 minus 2 over -8 minus -10. All right, so let's see, -6, -8. -6, -2 is -8 over -8 minus -10. That makes that a +10. So -8 plus 10 gives me 2. And so the slope of JK then is -4. All right, let's look at ML then. So let's look at the slope of ML. L is going to be our number 2 coordinates. M is going to be our number 1 coordinates, and so then we would have y2 or negative 3 minus 5 over 5 minus 2. Well, let's see. Negative 3, negative 5 is negative 8. And 5 minus 2 is 3. So our slope here, well, is just negative 8/3. And so JK and ML are not parallel. They don't have the same slope. And therefore, this can't be a rectangle. And I could really stop right there. Just in case we went in a different order, let's just look at JM right quick. All right, so that would be 5 minus 2 over 2 minus negative 10. 5 minus 2 is 3. And 2 plus 10, negative 10, 2 plus 10 is 12. So the slope of JM is 1/4. And let's see, KL, slope of KL, that's a negative 3 minus negative 6 over 5 minus negative 8 equals negative 3 plus 6 is 3. And 5 plus 8 is 13. They don't have the same slopes either. All right. I didn't really have to do that second opposite pair because I had already determined, probably would want to go back and double check my work, that these two opposite sides, JK and ML, were not parallel because they did not have the same slope. It's not always that easy. Sometimes you have to get in and start proving diagonals and whether the consecutive sides are perpendicular, but hey, we'll take it while it comes.